Good morning, fellow programmers. Thanks for joining me. I'm T-Pain, and welcome to Let's Learn Python. Feel free to use the skip ahead feature on the right-hand side to jump to any specific sections or examples. Today we'll be using Python 2.7.4, and you can download it from python.org/getit. Today we're going to be focusing on finite-state machines. This will build heavily on past lessons, so feel free to go back and watch them again if anything is unclear. Alright, a finite state machine. What is it? A finite state machine is a way of controlling or organizing logic in a program. It is commonly used to program AI or artificial intelligence. This could be for games, this could be for algorithms, this could be for any number of things. So breaking it down, why do we call it finite state machines? Well, finite means that there's a limited number. There could be 5, there could be 100, but there's a known number of states. And then what's a state? State is how something is in that exact moment. So if you're thinking about the real world, something could be hot, could be cold, could be liquid, could be gas, or it could be on or off in the case of a light bulb. Now, machine. What is a machine? A machine is a French rabbit who checks his mail. Just kidding. A machine is something automated. Yeah, I don't need to tell you. You already know what a machine is. Now, with the finite state machine, the program can only have one active state at a time, unless you program it otherwise, but typically only one state is active. Alright, so how do we use it? Well, first step is we plan. Creating a finite state machine can be tough, and it is imperative that you organize all your thoughts and get them down on paper or pen or digitally, whatever it may be, so you can visually see how everything's going to lay out. So here's my method of planning out my finite state machine. First, I'll draw out a whole bunch of circles for all the different states I need to create. Next, I'll draw arrows that represent transitions one way to a different state, connecting them and creating a network. Each arrow describes a condition as to why one state changes to another. It's important to label your arrows so that you know exactly what triggers the transition between states. For example, let's look at a finite state machine for a light bulb. It has an on and an off state, and that's it. We create those within circles. Next, we have transitions. We describe how one state changes into another. And that's as simple as somebody flicks the light switch on, or somebody flicks the light switch off. Alright, so let's go ahead and begin programming this light example I just described. Let's go ahead and crack open idle, and we're going to create a new file and save it to the desktop, and call it lightbulb_FSM for finite state machine.py. Save it. This is going to be about 70 lines of code we'll crank out, so brace yourself. Alright, let's get started. First, we're going to type from random import randint. And this randint function that we're importing is just a simple function to generate a random integer. Next, we'll type from time import clock. This will be used to keep track of the time of our program. These two functions combined are what we're going to use to actually iterate through different states very slowly so we can see the finite state machine at work. Next, we're going to type state is equal to type open parentheses quotation state close quotation comma object comma in parentheses comma open close squiggly bracket in the parentheses enter. And this is to create a state base class. That's all. Next, we're going to go ahead and create the two states for the light bulb. So type class light on open parentheses state close parentheses colon enter def execute open parentheses self close parentheses colon enter print quotations light is on in the quote. Then we're going to create another class after that for the off, and it's just going to be the same, so I'm going to go ahead and copy and paste and just change this to off and then down below to off. Perfect. So these are our states. I'm going to go ahead and start separating out our code into chunks. This will make it easier to navigate when we want to add more code. So I'm going to type enter pound sign, and then a whole bunch of equal signs. And then shift click to copy and then paste it below. And I'm going to do this a couple times. Okay, so we have our states separated in one section. And here we're going to create our transition. So type class transition, and it's going to inherit from the object class, colon enter. Type its constructor, underscore init, underscore underscore, and then in the arguments we're going to have self and toState, colon, enter, and then type self dot toState is equal to toState, and then we're going to include another function called execute, and it's just going to include self, and then we're just going to print transitioning. Alright, and that's our transition class. All that it's asking for is that when it's constructed, we pass in a toState, whatever state it's going to be transitioning to, and it's going to be as a string. So let's scroll down, and now we're going to create our finite state machine. So type class simple FSM, open parentheses, object, then we're going to access its constructor with self and char in the arguments, and the char is going to be our character that's going to be passed in when this object's created. So let's find that self.char is equal to char, and then we're also going to create a dictionary called states. And here's where we're going to store all of our states. Go ahead and save right now so we don't lose any of our work. And before we go any further, let's go ahead and make sure that there are no errors by compiling it real quick. So save, F5 to run it, and we have no errors. Cool. So let's continue. It's important to check to make sure that your program compiles correctly throughout it, rather than waiting until the end. Next, we're going to create a dictionary for the transitions. Self.transitions is equal to, open close parentheses, self.curState, and this is going to be to store our current state, is equal to none. And then we're going to do the same for transition. Trans is equal to none. Okay? So we're going to store our passed in character. We're going to have all the states within a dictionary and all the transitions within a dictionary, and have our current state and our current transition. Next, we're going to go ahead and create another function called setState. So type def setState, and in the arguments you're going to have self and state name, and down below type self.curState is equal to self.states, open parentheses, state name, close parentheses. And this is just a function that will look for whatever string we pass in within the states dictionary. So up above, when we create the states dictionary, it's going to be paired with whatever the state name is to an actual instance of that state. And this function is how we're going to set the current state to the past in state by passing in just a simple string. Down below, we're going to create a function for a transition. So type def transition, open parentheses, self, comma, trans name in the arguments. Then below type self.trans is equal to self.transitions, open bracket, trans name, close bracket. And all this function is doing the exact same as up above, but this is actually going to be setting the transitions state. Finally, we're going to create one last function. We're going to type def execute, open parentheses, self, close parentheses, colon, enter, if self.trans, colon, self.trans.execute, open close parentheses, enter, self.setState, open parentheses, self.trans.toState, in parentheses, enter, self.trans is equal to none. And finally, unindent from out of that if statement and type self.curState.execute, open close parentheses. So what's going on here is if there is a transition stored within self.trans, then we will execute that transition. We will set the current state to whatever that transition is to, and then we'll reset the transition to a value of none. And finally, we'll go ahead and execute that current states. So next we're going to create a character class, and this character is going to hold all the character attributes and properties. So if your character was going to have a weapon, armor, a helmet, whatever it may be, it would be stored within this class. The finite state machine would also be stored within the character class. Alright, so let's go ahead and create this class. Type class char, open parentheses, object, close parentheses. Then we're going to access its constructor. The init underscore underscore self. First thing we're going to do is create an instance of that finite state machine we created up above that says simple finite state machine. So we're going to type self.fsm is equal to simple FSM, open parentheses, self, close parentheses. And then we're going to go ahead and say self.light on is equal to true. And what's going on here is we're creating an instance of the finite state machine, and then we're storing this property called light on and setting it to a value of true. Alright, we're almost there, guys. Now at the very end, we're going to go ahead and basically create and run this program. So first we're going to type if underscore underscore name underscore underscore is equal to main colon enter light is equal to char. And this is to create an instance of the character. Next we're going to go light.fsm.states, and we're going to call one state on in a string. Set that state equal to the state that we created way up above. So type light on, open close parentheses. So what we did here is we created an instance of the light on state that we declared up above, and then we stored it within that state dictionary inside the finite state machine. Let's go ahead and copy and paste this down below and create the off state, and just replace that n with two f's. Next we're going to go ahead and create the transitions. So light.fsm.transitions open parentheses to on is equal to transition open parentheses on open close parentheses. Copy that line and paste it down below and replace those n's with two f's. Okay, save it. And what we did down here is we did the exact same thing. We created an instance of those transitions and stored them within the dictionary of transitions. Note that this string right here, on, matches the dictionary's instance of on up above. So what this is going to do is when we want to transition states, we're going to pass this string into here, and it'll spit out this state instance of light on. And the same for the off transition state. So next we need to actually set the initial state of the finite state machine. Light.fsm.set state open parentheses on close parentheses. And now we're going to create the main program that runs through this. So we're going to type for I in range open parentheses 20 close parentheses colon enter, and type start time is equal to clock open close parentheses enter, time interval is equal to 1 enter, while start time plus time interval is greater than clock open close parentheses in parentheses colon enter pass. So what this code is doing is saying for I in range 20, so we're going to run through this program 20 times. We're going to record the starting time and the time interval, which is going to be 1. And then here we're saying while the clock is not past 1 second, then we're just going to continue looping on it. Once the clock has passed 1 second, we're going to move on below. Next type if randint, that function we imported above, open parentheses 0, 2 in parentheses colon enter, if light on open parentheses colon enter, light.fsm.transition open parentheses to off in parentheses colon light on is equal to false. And then we're going to type an else statement to reverse it. So let's just copy these lines above because I'm lazy, paste them below, and then we're going to replace this false with true and put to on right above. Save it, press enter, unindent all the way back down, light.fsm.execute. Alright, so what's this next block saying? Well, this random integer is going to pick a value between 0 and 2, which is going to result in integers 0 or 1. If it's 0, it's just going to skip everything below and just execute whatever it currently is. It's not going to change states. Otherwise, it will trigger a transition to whatever the opposite state is. So if the light is currently on, we're going to transition to off. Otherwise, we're going to transition to on. And that's it. Go ahead and save it. Let's shrink this down. So note there was a little error. I had a typo at line 60. I'm going to go ahead and fix that real quick. That's right here. All I needed to include was S for the plural. Save it, run it again. And I got another error in which I had not spelled the state transition right. Run it again. All right, now it's working. So it's saying transitioning whenever it's transitioning from an on to an off state, and we're just switching between the on and off states of the lights and randomly picking which one we want to have on. And after about 20 seconds, it'll stop. Perfect. And the program ended. Beautiful, beautiful. Alright, so our program worked beautifully, but what about like longer and more complex examples? Well, rather than sit here and type for like 2 hours and showing you how to create a longer example, I'm actually going to zip through one that I already created. This one is called FSM underscore robotmade.py. And you're welcome to pause the video and type this out for yourself if you'd like. In fact, I'd encourage it. It's important to note that there are many different ways to create a finite state machine. I'm merely showing you one way, but what's most important is the concept, not so much the way you implement it. Alright, so again, I imported the clock and the random ints to keep track of time and integrate through this code. Here's my transitions, same as above that we created. Next we have states, we have a base object, and here I have 3 functions rather than 1. In the previous light example, we had 2 functions. We had the execute for the main state, and then we had the execute for the transition, and that was it. But that may not be enough. In fact, in most cases it won't be. You'll need 2 additional functions, the enter and the exit functions in each state. The reason being is, say for instance, you were going to do the dishes. When you started to enter the state, you would turn on the sink, and then in the execute you'd actually clean the dishes, and then when you got done, you would turn off the sink. And this happens for everything. You could have a simple pass in here if it's not going to do anything, but it's important to have enter and exit functions as well as the main execute. The enter and exits will only be called when there is a transition happening. So the first state that I actually created is this clean dishes state. I'm going to expand this a little bit. So in the constructor of clean dishes, I'm going to go ahead and call the constructor of the base state class right here. And I'm also going to ask that a finite state machine be passed into the constructor so we can make adjustments and grab data from it. Next I print preparing to clean dishes. Next I initiate the enter function from the inherited state, which will just create a simple timer as seen right here. In the execute I have the print dishes so we can do whatever task we want, and it's important that we have a condition within the execute of the state that we are in to check to see if we need to transition to another state. If the condition is met, then the finite state machine is triggered to transition to whatever condition we want. In this case, I have the program randomly choose if it's going to vacuum or going to send the robot to sleep. Finally, I have finished cleaning dishes as the exiting print statement. Now we're going to scroll down to the vacuum state below. And in the vacuum state, we do the same before. We initialize the constructor of the base class. And then within the enter function, we call the enter function of the base state class to initialize the timer. And then we have that check within the function to see if we need to trigger a transition to a new state. And then we randomly choose between the sleep and cleaning dishes function. And finally, we finish vacuuming. And at this point, everything's starting to look exactly the same. And for the sleep state, everything's just exactly the same as the other 2 functions. We print starting to sleep. We call the enter function of the base state class to start the timer. And then in the execute, we have the transition to the other 2 states. And finally print that we're waking up from sleep. And that's it. So here's the finite state machine implementation. And this is very similar from what we did above. We have a dictionary for states, transitions, we have a current state value, and we also have a transition value. We also store one more type of state in here, the prev state or previous state. This previous state is used to store the last state that the robot had. This is to prevent the code from looping on itself. I didn't actually implement it in here, but you should definitely implement it for more complex problems or programming, just so the program doesn't loop on itself forever. Next we have a function to add transitions and add states. This is just a cleaner way to add something to a dictionary. Ordinarily, you'd have these variables, states and transitions, as private. In other words, outside classes and objects would not be able to access them directly. And that's why you'd implement the add transition and add states, just so that they could put them in, but they couldn't remove them. And then just as before, we have the set states, but this time we store the current state into the previous state and then pass in the current state. Down below, we have the to transition state to set the current transition. Finally, we have the execute function, in which we check to see if there is a transition state set. We then, if it is set, we call the exit function of the current state. We execute the current transitions function. We set the state to the transition's target state. Then we call the enter function of the current state because it's been changed over to the new state. And finally, we reset the transition to a value of none. And lastly, we execute the current function. Cool. And down below, I'm going to scroll down. So next we have a simple base character class, which has just inherits from the object, and that's it. Then we have the robot made class, which inherits from the base character class. And here's where we add the states that we declared above, we add the transitions, and then we set the default state to sleep. Finally, our function that says execute on our character just executes the finite state machine. That's it for the character class. And here's our final implementation of the actual code. We check to see if we're in the main file, we create an instance of the robot made, and then we integrate through 20 different times through this code using xRange. We have the start time, time interval, and we have this while loop so that we know that it's going to interval every second and call the code. Okay? And I'm going to change this xRange to 10 just so it's quicker for demonstration purposes. And then we just keep calling execute. That's it. We just keep calling it. And we're like, hey, has a second passed? All right, then execute. A second passed? Execute. Let's go ahead and run it to see it in action. Okay? I'm going to press F5, and here we see our code working. So it starts off sleeping, then it transitions to cleaning dishes, and then it's sleeping again and transitioning cleaning dishes. Now it's vacuuming, it's going back and preparing dishes. Perfect. The code worked beautifully. Awesome. Alright, lastly, why do we use finite state machines? Well, if we didn't use finite state machines, we would have a huge amount of code that would just be if and else statements that would look terrible, that would be very difficult to navigate, and very difficult to manage. If you'd like to learn more on this subject, I recommend Programming for AI by Example, and there will be a link down below in the description. Thank you so much for watching. Great job keeping up. Definitely take a few minutes to investigate these final challenges. You are a brilliant programmer, and I'm sure this will be a piece of cake for you. Please leave me a comment below if this helped you at all, and please do me a huge favor and subscribe to my channel. It would really mean a lot to me. Thank you so much for your support, and keep the dream alive.